Hi class. Today in this video, we're going to be covering the regression basics still, but the computerized portion of it, how to do a regression on the computer and how to interpret it. And I'm going to do several examples from your book and a couple from the data actually that I pulled when I did the paper example video. And I'm going to start with problem 16.2 in your book, which is on page 644. And I took the data and I put it into this format that you see here. So we have sales numbers and advertising for each month. I put sales first because it's your dependent variable, and in your for your paper I instructed you that you should do dependent variable first. Okay? So here's our data. So I would suggest that you pause the video now and set this up yourself on your computer so that we can do it all together, but it's up to you. Okay? Alright, so part A says, please draw a scatter diagram. Does it appear that advertising and sales are linearly related? Linear means the straight line, right? So the first thing we're going to do is draw a scatter diagram. Now we could do this we could draw this by hand, but we can also do it on Excel. So that's what we're going to do. I'm going to show you exactly how to do this. You're going to highlight those two columns of data and then go up here to Insert, and then we're going to do a scatter plot like this. All right, now we have an issue here because it actually put it in the opposite order that we want. It has the y-axis as the x-axis and vice versa. I want to get advertising on our x-axis because it's our independent variable. So here's what we're going to do to change it. Hopefully I'm going to get this right the first time. If not, be patient for me, okay? So I'm going to right click and I'm going to go to select data. Oh, whoops, sorry. I'm going to go to select data and then I'm going to click here on add for add a series. So this brings up edit series, and so what we're going to do is we're going to change this. We're going to do exit series X values. Our X is our dependent variable. Our independent, I'm sorry. So I'm going to select the numbers for advertising. And then for Y, I'm going to select the sales numbers. And I'm going to hit OK. And then I'm going to take this series 1 and I'm going to unclick it. That's the first one that was there that I don't want anymore. Okay, so I just added a new series. Okay, so now it's right. We have advertising on the x-axis and sales on the y-axis. If you're turning this in for homework, you would want to put labels on there, titles as well. But don't worry too much about that right now. You can figure that part out yourself. All right. So does it look like these are linearly related? Well, I would say so, as it looks like as advertising dollars go up, sales go up as well, right? So I can imagine the line that would be drawn through that, and you actually can, I believe there's an option to do that. Let's see here. To be honest, it's terrible, but I don't know exactly how you draw the line of best fit in there, but you guys may be able to figure that out more easily than I can. Actually, let's go in and look at this. Let's see. Line of best fit, scatter plot, Excel. This will be a good example too of how I would personally try to figure this out if I were you guys. Okay, 1 second. Chart menu. Click once on the chart, go to chart menu, add trend line. Let's see if this works. I'll believe it when I see it. let's see, format chart area, chart options. I'm going to go to the plot area and see what shows up there. No, I'm a little disappointed. Let's go back and see what else this says. Okay. We have that. Make a table. We've done that. Okay, here we go. In sheet 1 at the top row, Excel, insert chart. Then next, click on the ordered pairs in your graph. Click chart and add trend line. Oh, here we go. Okay, great. That worked. All right. So what I did was I clicked on the dots. I right-clicked and add trend line is right here. And then we can choose, and linear is what we want, and there it is. Yay. That's exciting. Okay. So that's an example of how this is the new Excel. Actually, this is I bought a Surface Pro a few months ago. And I'm still not used to using this version of Excel because I have the different version in my office, so I'm a little slow with this one. But anyway, there's our trend line. And does it seem like they're linearly related? Yes, I would say so. It seems like there is a positive relationship. Okay, but we can't just tell by looking at this graph. We need to run a regression as well. So part B here says calculate the least squares line and interpret the coefficients. I no longer expect you guys to do this by hand. Okay, you can do this using the computer. That's the beauty of having statistical software now in good old 2015 is that we can do this using software rather than having to do it by hand now. Okay, so what do? Now let me see if I do not. Okay. So we talked about one time before about adding the Data Analysis Plus. I'm going to go through that again with you now. You must do this every single time you open a university computer. If you have your own personal computer, it will stay on there. Okay? All right, so here's what we do. We go File, then Options, then Add-ins. Then this first one up here, see this Analysis Toolpack, that's what we want. Now, instead of hitting OK, you hit Go. Then this Add-ins box pops up. We'll click Analysis Toolpack, hit OK. Excuse me. Okay, so once you do that, if you click up here on your Data tab, you will see there's a Data Analysis option. So we're going to click there. Okay, now this pops up. So we are going to go to Regression. Hit OK. And this is very easy, okay? For our Y range, we're going to take sales, right? That's our dependent variable. And I want you to take the label of sales and scroll down to the bottom. And then for the X range, that is advertising. So select that, go all the way up to the labels. Now, you must click labels here. That tells Excel that the first row of each column are labels, and that is how it's going to label the results. You want to have that there because especially once we start doing multiple regression, it's really confusing if you don't have the labels. Okay? I think that is all we need, okay? And so we now are going to hit OK. And up pops some output. Now, next week, we're going to learn about how to determine whether or not this is a significant relationship. And I actually will tell you in this case it is, but we'll learn how to determine that next week. For now, though, I just want us to focus on a few things. Okay? First of all, what is the regression line? So, remember, we have, I'm going to make a pen where I can write on here. remember we have predicted y is equal to beta 0 plus beta 1x, right? So in this case, our y is sales, right? So we're trying to predict sales. So how do we do this? Well, predicted sales is equal to, what is beta 0? Well, it's this intercept, okay? It's this number right here. So we have predicted sales is equal to 9.1004, okay? Plus our beta 1, what is beta 1? It is this number here beside advertising, 0.058 advertising. Okay, this is our regression line. So when it says calculate the least squares line, this is the least squares line. What does this tell us? This tells us that the y-intercept is 9.1004, that's beta 0, and that the coefficient, our beta 1, our slope coefficient, is 0.058. How do we interpret this? It says interpret the coefficients. Beta 0 is easy, right? This means if advertising, since it's the y-intercept, it means if we spent $0 on advertising, we would expect sales to be $9.1 million. Okay? That's what a y-intercept tells you. Now, in some cases, that makes sense. Here it does. But imagine if you had age on the x-axis. It would make sense to say if somebody was 0 years old, they would make this many thousands of dollars a year. That would make sense, right? But in this case, it does. If you could theoretically spend $0 on advertising, and the model predicts then you would have $9.1 million in sales. All right. What is much more important is the interpretation of beta 1. And here, remember, we look at it, what happens to y when x goes up by 1? X in this case is advertising budget, which is in thousands of dollars. So the way we interpret this is the following. When advertising increases by $1,000, right? Because a 1 unit increase in this case is $1,000. So when advertising increases by $1,000, sales increase by, now this is going to be 0.058 million, right? Because sales are in million. So what is 0.058 million? Well, think about it. 0.1 million would be 100,000, right? So 0.058, this is 58,000 on average. Okay, that's how we interpret that. Now I'm going to look back in the back of your book and see how your book writes this out to see if it's consistent. All it has is the regression, which it has the results are the same, but it doesn't have the interpretation. But the interpretation, I would say, is when advertising increases by $1,000, sales increase by $58,000 on average. Pretty good return. Okay? All right, let's do another one. For the next one, let's do $16.6. Okay, so 16.6 in your book. Okay, I've pulled up the data for problem 16.6 in your book. I'm also going to post this data set on Blackboard. So if you're watching this, you can go into Blackboard under the folder for the videos in lieu of class for this week and get this data set as well. Okay, so let's read the problem. In television's early years, most commercials were 60 seconds long. Now, however, commercials can be any length. The objective of commercials remains the same: to have as many viewers as possible remember the product in a favorable way and eventually buy it. In an experiment to determine how the length of a commercial is related to people's memory of it. 60 randomly selected people were asked to watch a 1-hour television program. In the middle of the show, a commercial advertising a brand of toothpaste appeared. Some viewers watched a commercial that lasted 20 seconds, others watched one that was 24, 28, 60. 44, it looks like 52. Okay, different amounts. The essential content of the commercial was the same. After the show, each person was given a test to measure how much he or she remembered about the product. The commercial times and test scores were recorded. Okay, so it looks like in this case we're going to be using columns A and B. Column C doesn't seem to be relevant to this question. Part A says draw a scatter diagram of the data to determine whether a linear model appears to be appropriate. B, determine the least squares line. And C, interpret the coefficients. Okay, so the first thing we're going to do is I'm going to highlight test and length. I'm going to forget about that type variable. And I'm going to highlight those. And then I'm going to insert a scatter diagram. Okay, and let's see, it looks like I have, it's way down there. I'm going to move this, nope. One second. Some things are hard to do without a mouse, and this is one of them. Okay, I got it fixed. I'm going to move this whole graph up some. I don't want it so low down. Okay. So I want to have my test is my dependent variable and the length of the video is my independent, and it looks like those are flipped around just like we had before. So I'm going to go in and do what I did last time, which was right click and select data, and then I'm going to go in and add here. That pops up this edit series, and then I can select my x-axis, which that's going to be the length of the videos. And I'm going to do my y, which is going to be here. Oops. Here on A. And then I'm going to hit OK. And then I have to go in here and delete this first one, this one that's titled length, okay? Once that goes away, we'll be good. Okay, so here is the scatter diagram. And remember what we did before, we can click on an individual one and right click. Oops. Some of this stuff is tough with the Surface Pro. This is one of the things that's tough. And I'm going to add a trend line. Okay. Now, here it says, does it appear to have a linear relationship? Not really in this case, right? This scatter diagram seems to be all over the place, to be honest. Now, if I look at that trend line, it's slightly upward sloping, but I'm going to say it doesn't look like there's a strong relationship. But let's do our least squares model just to make sure, okay? So I'm going to go to Data, Data Analysis, pull up Regression, hit OK. And I've got let's look at this again, sorry. For my Y range here, I'm going to select, remember we want to select the title. Oh, sorry, for my Y I actually need the test, right? It's how much the length affects the test score. And then for my X range, I have length. Oops. Make sure I've clicked on labels, hit OK, and here it comes. Once again, we'll talk about this, how to interpret whether or not there is a positive or negative relationship here. Or whether or not it's significant, I guess I should say. We can see if it's positive or negative, but whether or not it is significant. All right, so how do we write this out? So we have same thing we had before in terms of the way we write it out. So remember, we have predicted y is beta 0 plus beta 1x, right? And here we have we want predicted test score, and that is equal to our intercept, which is 3.636 plus 0.267 length. And you know what? Actually, this is a significant relationship. It surprised me because, once again, if we look at this, doesn't really look that significant, but it is. So you can't always tell. It is just slightly different from 0. And you do see that the slope is not high, right? I mean, it's 0.267. So what does this mean? Now let's look at this again. The length is in seconds. And the test score, we don't know exactly how that's measured. I guess maybe it's 0 to 100 like a normal test score. I don't know. But if we were going to interpret this, we would have as, oops, turn my pen back on. When commercial length increases by 1 second, remember, you always do it in the unit of analysis. Here, the x value is number of seconds. So when commercial length increases by 1 second, test scores increase by 0.267 points. Okay, that's how we would interpret that. Now, in this case, that beta 0 doesn't really make sense to interpret it because you wouldn't have a commercial of length 0, right? It has to be, I mean, the minimum it had here was 10, I think, is that what it said? Let's see. No, 20. 20 was the lowest, okay? So we wouldn't interpret beta 0 in this case. But beta 1 is when commercial length increased by 1 second. Test scores increase, by 0.267 points on average. I almost forgot about that. You got to put on average, right? Or are expected to increase by 0.267 points, right? Okay, now I want to show you something that I talked about in the video before about the error term. Okay, we can take this equation and apply it to our data, and I will show you. I'm going to prove something to you. So let me write this out for myself really quickly so I can use it. All right, so if I go back to the data, I'm going to first of all delete this type column. I don't need this. Okay, now I am going to make a column for predicted test. Okay, this is going to be my predicted y. And I'm going to literally plug in the value into the regression equation. So we have that predicted, I'm going to do equal sign, predicted test is equal to 3.636 plus 0.267, this is what we just got from the regression equation, times the length of the commercial. What do I have wrong there? Oh, I forgot to do the multiplication sign. Okay. And so I can then copy this down. Okay. So in each case, we have 3.636 plus 0.267 times the length of the commercial, right? Now, these are the predicted scores. Now, some of them, like in this first case, were predicted 17.52 and it's really 24. Next one, 14.36 is really 20. Those are higher, right? But we'll see some that are lower. Here for row 6, the prediction is that it would be 15.384, but it's only 10, right? So some are going to be higher, some are going to be lower. As we can see, the chart beside it, some of the values are above the line, some are below, right? Okay, so now I'm going to calculate the error term. All right, now the error term, remember, is the difference between what is predicted and what we actually see as the result, right? So we have the actual observed value minus the prediction. So for each one, in this first one, I'm going to have the actual value of the test, which is 24, minus the predicted value. Okay, hit enter, and then I'm going to, hopefully you guys know, but if you click on that and then double click on the bottom right where that bigger square is right here, it'll copy it all the way down for you. Okay, so some are going to be positive and some are going to be negative. Some are going to be very small, right? This is right here, row 9. This is a very good prediction. Some are much larger. Here we have one down here that's negative 14. But hopefully you remember when you watched the other video, what is the expected value of the error term? Well, it's 0, okay? And when I average these out, now it may not be exactly 0 just because of rounding, but it should be really close. Okay, yep, and indeed, we have that the average value is 0.018. That's only because of rounding. If we didn't round it all, we would get a flat 0, okay? So the average value of the error term is 0, even though the error term, you know, that for each one, it's different. But if you add them all up, the average is 0, okay? All right. Let's do one more example, and for this I'm going to use an example of the data that I collected for the paper example, where I looked up the business start data and then the percent of people with a bachelor's degree or higher. Okay? Alright, so I'm going to jump right into the regression here, just so that this video is not super long. I'm going to hit OK. For my Y range here, it's business starts. This is the number of businesses that are started. I have my 50 states, right? And then for my X value, it's the percent of people with a bachelor's degree or higher. So I'm interested to see, you know, do states with more college graduates have more business starts in 2012? And I've clicked my labels. Here is my output. Once again, we'll cover next week whether or not this is significant, but let's just interpret it for now. I'm going to interpret a couple other things that we haven't done quite yet. Okay. So, first thing we want to do is we want to write down the regression line, okay? Just like we've been doing. Okay, so I'd really like for you to pause it and write down what you think the regression line is, and also go ahead and interpret that beta 1 for me, okay? So go ahead and pause it and give that a try, all right? Come back when you've done that, and I'll have it written out here. All right, so here we're trying to predict business starts, all right? So predicted business starts are equal to 1,733.65 I always want you to go at least 3 places afterwards to minimize rounding errors. Plus 439.309 times, I'm going to put BD for bachelor's degree. Okay? So how in the world do we interpret this? Well, this is a little different because, you know, here's our beta 1, but this time our data is different in that bachelor's degrees are in percentages, right? So, and business starts are in regular numbers. So here's how we interpret this. Gotta get back to my pen. If the percent of adults with a bachelor's degree or higher increases by 1, this is super important, percentage point, not percent. Let me show you why this is really quickly. Let's say we were going from 10. A percentage point increase would take us from 10% to 11%, right? That's what we're actually interested in. This is a percentage point increase. A 1% increase would take us from 10% to 10.1%. That is not what we want. Okay, this is not what we want. No, no, no. We want percentage point. Okay, so if the percentage of adults with a bachelor's degree or higher increases by 1 percentage point, we expect business starts to increase by 439.309. Okay? Hopefully you're able to get that. So let me ask you this. Let's say, erase this ugliness right here. Let's say I asked you the following. How many business starts would be expected in a state with the bachelor's degree variable equal to, let's say, 23%. How many business starts would be expected in a state with bachelor's degree or higher equal to 20%? Okay, well, we can do this. What do? We take our business starts formula here and we say predicted business starts is equal to 1733.641 plus 439.309 times 23. Get my calculator. So 439.309 times 23. This is 1733.641 plus 10,104.107. So 11,837.748. Okay, there's our answer. So you just simply plug in the value, and we'll do this more and more next week as well, but you just plug the value in to the regression equation. Okay, and if you look, you know, some states, like Texas has almost 60, so that value is reasonable, right? 11,837 is reasonable. All right, one other thing that we didn't cover yet is on this is the R squared. Remember we talked about R squared and the standard error? the standard error is much less important than the R squared here. Here is the standard error of the regression, 17,720. This is large, but this shouldn't surprise you because we didn't make a chart here, but you would see that it's quite spread out as well if we had made a scatter diagram. But we do have our R squared, and this shows that this model is not very good. Here's our R squared. What does this mean? This means that 1.67% of the variation in business starts can be explained by the percent of adults with a bachelor's degree or higher. That is tiny, 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 tiny. Lots of what we call omitted variable bias here. What does that mean? We're only looking at this one small thing, so there's a lot of bias in this model because there's obviously a lot of other things going on. Okay, now I am going to, that's it for right now, but I am going to save this file, and I'm also going to save the other file on Blackboard like I promised so that you can go in and try to recreate these results. Okay, make sure you watch this carefully. Watch it a couple times if you need to. Heck, watch it 10 times if you need to. Please also contact me if you have any issues at all or have any questions. Okay, thanks a lot. I hope you guys have a great weekend and good early next week. And I look forward to seeing you pretty soon. Bye.